Hi, this is Suey778 coming at you, and I got yet another multimeter review. Now before we get into this, yeah, I know I've been inactive for a while, but hey, life happens, work happens, situations happen. Anyway, I'm back, and this is a meter that I've had for actually about a year and a half now, and I've just never gotten to it. So I do want to say thanks to Kimberly from Kaiweets for sending this to the channel for review. Sorry it took me so long to get to it, but we're getting to it. So this is the Kaiweets HT118E as an echo, 20,000 count digital multimeter. So without further ado, let's get to it and let's see what's in the box. As you can see, you get, kind of a little bit flashier box than you got in the HT118A. But anyway, let's open this puppy up and see what we get inside. Okay, everything comes in a case. So what do we do with the box? Get it out of the way. Okay, so inside the case, we get a user manual. This manual is actually in multiple languages. Fairly thick, actually. So here's some specs for it. Hold them up there for you. Okay, here's the next page of specs. If I can get my hands to quit shaking. There you go. And I think we got one more page of specs. Yes, we do. And there are those. So you can pause it and take a look at them if you'd like. It's pretty small print. Anyway, that's going to do it for the manual. Also inside, you get a pair of AA batteries. Thermoprobes. Set of leads. And, of course, the meter itself. All right. So there it is, the HT118A in all her glory. Let's get this thing powered up and let's take a look at it. Okay, and before getting started, I just want to mention that this particular meter is available at Amazon. Basically, this meter is a progression of none other than this guy, the HT118A, which is the 6,000 count version, and I reviewed this I think about 3 years ago or so. Basically, this has the same layout, features, and functionality except for a couple of major differences. Number one being is the count resolution. Let's go ahead and turn it on and get the backlight on. The other thing is that you will notice in this meter right here in white it says digital multimeter. On this one, it actually shows it as digital multimeter 20,000 counts, if you can see that. Anyway, but these two meters side by side are virtually identical. The one other major difference that I can think of right off the top of my head is on the milliamp input. On the original, on the A model, you could do up to 600 milliamps maximum. On the new one, you can only go up to 200 milliamps. Same 10 amp jacks, same COM jack, same function jacks. The functions in these are identical, so I'm not really going to go through a tour of them. As you can see, the same functions: function button, hold button, max min, flashlight, and backlight. And the switch and this rotary switch is exactly laid out the same way, same features. So there you go. Anyway, so basically I would call this a category 2 250 volt multimeter. We'll go ahead and put that aside for right now. There's really, like I said, there's not a whole lot to say even about the insides. I'm not going to do a teardown on this particular multimeter, just simply because honestly what you're going to find inside is exactly identical to this. If you want to see it torn down, there are plenty of other videos out there that do it. But these have virtually the same thing. The only differences that I really can see that are worth mentioning is the resistor acting as a current shunt in the E model is a little bit larger than the A model, and the other maybe a little bit heavier protection with the resistor. It's just not much. Basically the same 2 PTCs of protection on input protection and no MOVs. Anyway, so let's go ahead and get set up for this. I will go through the this really quick just to make it look, just to go through the features. So what you get here is, oh, and this is the same always on light as you get with the Alpha model, so that's cool. So you get AC DC voltage with Hertz reading, that's on AC only. AC and DC millivolts, Hertz and duty cycle, resistance, continuity, and diodes, capacitance, temperature in both Celsius and Fahrenheit, and it is, yeah, it's not reversible. So you get the Celsius in the little numbers and Fahrenheit in the higher, in the bigger digits. AC DC microamps, again with frequency reading on AC side only. AC DC milliamps, amps, AC and DC. And of course you get your NCV and live. Oh, it's already beeping at me. But anyway, those are the basic features. As you can see, exactly the same. There's really not much to say. This is pretty much the same meter, in theory anyway, as the original HT118A was. So let me go ahead and get set up for the reference checks. We're going to use, of course, my DMMCheckPlus, my AD584M. As you can see, I got these warmed up, or warming up. The Fnirsi SG-003A for the current test. And of course, as always, the homemade PCB test board. And of course, we're going to use the arbitrary waveform generator, which I have off camera right now. It's kind of back over here, but we'll get to that. And I believe that's it. That's about all we're going to do with this. Anyway, so let's go ahead and get set up and start doing some testing. Okay, we got the DMMCheckPlus here ready to go. So the first thing we're going to check is DC voltage. So let's go ahead and get the these little grabbers on. And as always, I am using my Probe Masters, as I have tested multimeters with in every other video. And one other thing to say here, I have not had this DMMCheckPlus recalibrated, so it is slightly drifted on the voltage a little bit. I think everything else is pretty much held up the same, but as you can see, we're getting about 4.996, 4.997, so that's just about right on. All right, let's go to AC and see what it does. Switch it up here. And on AC, it's getting about 4.966, which is about what I was expecting for a multimeter of this caliber. So not too shabby there. All right, let's go ahead and let's go ahead and do the resistors. And I do believe there was a frequency there. I didn't mention it, but it is reading the frequency of 100 Hertz. As a matter of fact, let's check that, since I kind of forgot to do that. Yeah, I'm a bit rusty. It's been a while. Okay, Hertz, so getting a perfect duty cycle of 50%. The frequency for this is supposed to be 10.009228 Hertz, so technically it should be reading as 10.01. That's so close, that's not worth worrying over. And again, there may be a little bit drift, but either way, that looks really good. All right, now let's go to the resistors. Okay, first up is going to be the 100 ohm resistor. This should read as 99.99 ohms. And we are getting 100.35. Now, one thing I should mention about this too, and this will become a lot more evident once we get into capacitance, but you're going to see that we have an issue with having no rel feature. So it's reading it as 100.29. Now, it is possible that this is drifted some, but let's see what, just real quick here, let's see what my my other one says, my bench meter. Let's go ahead and plug these in here and see what we get. I have a feeling it's going to do a little bit better, but let's see what happens. And it's actually reading it as 100.01. So yeah, it's closer. So there may be a little, again, a tiny bit of drift, but I don't think enough to worry with. All right, so let's continue on with the test as we get these patched back in here. All right, next up is going to be, the next one is supposed to be 1.0005 kilo ohms. And it is reading it as 1.011211. Pretty darn close, I'd say. All right, next one is going to be 10.0044 kilo ohms, so it should be reading it as about 10.01, I would guess. Actually, I think we get a third digit here. We do. So it should be 10.004, and it is right on. Look at that. So for that scale, that's absolutely correct. So no problem there. All right, let's go to the 100K resistor, and this one is supposed to be 100.064, so we should be seeing 100.06, and it is reading it as 100.01. Again, it's pretty close. Yeah, pretty close. A little bit off on that one, drifting a bit, but I'd have to give that a pass. All right, let's go ahead and switch over to the capacitors here. Okay. Well, as you can see, we've already got a problem. We have no relative feature, and we cannot get rid of that. As you can see there, we've already got 40 picofarads being measured, and I haven't even connected them yet. So when I put these in here, we're going to start off with the 992 picofarad. That actually helped it go away. There's really nothing we can do about it, so all we can do is measure. Actually, there is something we can do. I'll show that here in a second. So 992 picofarads, and like I said, that lack of rel feature is really killing this. It's off by about, say, 20, 25 counts. I'm too tired to do math. All right, let's try the next one. This next capacitor should be 10.07 nanofarads. And again, yeah, that's a problem. It's reading it as 10.102, so yeah, that's about 32 counts off. It's not terrible. I mean, but I've just seen meters do better when they have a rel feature like this. And as you can see, this is climbing. And I've seen it go as high as like 100, 150 picofarads, and that's not good. Okay, next one is supposed to be 100.6. It is reading it as 100.7273, so that's really close. That's perfectly acceptable to me. All right, and the next one is the tough one. This is the, if I can get my clips in there, this is going to be the 1.007 microfarad. And it's probably going to read it a little bit high. And yes, it does. It's reading it about, I'm going to say, significantly higher. Yeah, 10.007. It's reading it as 10.042. So we're at about 350 picofarads too high there. But let's try something else with this to help mitigate that problem. So these are my leads. We're going to use some shorter leads. These are my leads for this little Roshi 4080 LCR meter that I have. I'll probably do a review on this at some point this summer. But anyway, So let's use its leads and let's see if we get better results. I mean, since we are using shorter leads to measure capacitance, it should help, but let's find out. Okay, and we're going to have to get this out of the way. And we're going to need to move this over so we can reach it. So we're going to put this right here, just so you can see that I'm actually connecting it. All right, so let's try that again. So here's the 992 picofarads. I really hate these clips because they are very fiddly. And as you can see, it's supposed to be 992 picofarads. That's considerably better. I think it's doing a good bit better there. It's only about 18 picofarads off, so that's pretty decent. All right. All right, so let's go on to the 10.07. I think we're going to see an improvement with this also. And sure enough, look at that, 10.086. That's much better. That's only about 16 picofarads off. I'll take that. And next is the 100.6. Again, I don't know that we're going to see a whole lot of improvement here, if any, but let's see what happens. And actually, yeah, we got a few counts closer. It's supposed to be 100.6. It's reading as 100.7. So yeah, that's very acceptable. All right, and the last one. I hope I'm not bumping the camera around here. It doesn't look like I have, but yeah, these cheaper alligator clips are no fun to play with. All right, I got it on there. Let's see what we get. And again, that reading is about the same. So like I said, it's a real shame that, you know, we couldn't reel it out before we did the measurement. But that's just slightly above average of what standard multimeters did. This one, I think, only did about 14 counts better. So that's, again, that's not a real big deal. But to mitigate the real issue, especially with lower readings, and we'll show that here when we get into the capacitance test, use shorter leads. That's the bottom line. Okay, and let's see. One other thing we need to do with this is the current, because we did not do the current. So let's go ahead and do that. Let's get these out of here. But those short leads are very handy to mitigate that problem. And as you could probably see in there, when I patched them up, they, you know, we were getting no readings. At least I don't think we were. I think it was reading 0 but in any case, they did a better job. That's the bottom line. All right, let's get these back over here. We get this into milliamp range. No, not this one. Stupid. Like I said, I'm out of practice. All right, so we're going to go to DC milliamps. Let me get that switched over. Let me get this patched in. Okay. All right, so let's get the ground on. So fortunately we're not getting any noise here, but anyway, for this DC voltage rush, this should be I'm sorry, the DC current source should be 0.9996 milliamp. And we are getting 1 milliamp. Well, okay, basically 1,001 microamps. All right, let's put it down to the microamp range and see if that does any better. And 1000.2. So it ain't off by much. That's pretty darn close. I'll take that. All right, let's go ahead and keep it in microamp and change it over to AC. What's it complaining about? Probably there we go. That's good to know that it's even going to complain to you about using the wrong type of current. Shouldn't hurt it. But anyway, so this is supposed to be basically 1,001 microamps. We're getting it as 994.3, which is pretty close. Let's go up to the milliamp range. See, is it going to complain about that too? No. Interesting. And it is reading it as 992, 993 milliamps, so the microamp reading is actually better. All right. So if you're down that low, obviously take advantage of the microamp range. So overall on the DMMCheckPlus test, I think this did pretty well. The problem with the no rail feature to mitigate some of that, the pre-readings on the capacitance is a bit of a disappointment, but other than that, I have nothing to complain about here. Okay, so as you can see here, I've already got the 32 volt power supply turned on. I figured we'd just do this first. And as you can see, we're getting the pretty much the standard reading of what I would expect to get from my reference meter here when it's been on for a few minutes. And the Kaiweets is picking it up as 32 volts. Absolutely no problems there. All right, let's go ahead and go over to the AD584 or AD584M. This, by the way, does have a KH chip in it, for those of you that are wondering. You really have to squint at it to see it, but it is there. Okay, all right, so let's go ahead and do this. I'm going to start with 2.5 volts. Let's see what these get. Okay, on the reference meter, pretty much right on. It's usually 2.5007 or 006 depending on the temperature. It's actually running a little bit lower tonight, probably because it's a little bit warmer. It does tend to drop a little bit, I've noticed. Okay, and the Kaiweets is reading it as 2.499. I have absolutely no problem with that. That's really close. Okay, 5 volts. Again, 5.0055, which is right on again, and the Kaiweets is picking it up as 5002, and that's going to make it about 15 counts off, 13 count, yeah, 15 counts. So that's not too bad. It's actually, you know what? It's reading it a little bit low. So it's about 25 counts off. 35. Still, though, pretty good. All right, let's go to the 7.5. Again, standard 7.502 with a little bit of waver up and down 1 count. And the Kaiweets on my UT8804N, and the Kaiweets is reading it as 7.497. Again, really, really close. Just slightly short, but not enough to worry with. All right, let's go to 10. Getting the standard 10006, 10007 there. And the Kaiweets is reading it as 10001. Again, I'd say it's like 5.5 counts off, because it is, yeah, we'll just say 5 counts off, because it is tapping one there a lot. But, I would say it's a pretty safe assumption that the Kaiweets HT118E is good on voltage. Okay, here we go with the current test with the Fnirsi SG-003A. I'm going to start off with 4 milliamps as we do as usual. And, of course, I've got the HT118E set up in the milliamp range. Okay, here we go. That's 4 milliamps and is reading as 4.01. Slightly high, maybe 3 or 4 counts high. Not too bad there. Let's go to 7. Okay, 7.018. Again, slightly high, maybe 6 or 7 counts. Not bad though. Okay, 10. Again, about 7, 8 counts high, but again, not bad at all. Pretty close. 15. This should be about 15.038. It's reading it as 045, so yeah, again, that's very reasonable. And last but not least, 20 amps, or 20 milliamps, and we are getting a reading of 20.05. So it should be like 20.04 something. So again, I'm not complaining about that. Really good, pretty good accuracy on current. Okay, here we go with the continuity test. Let's get it in the right mode here. I can tell you these are what the leads that come with the unit. I can tell you already I don't like them because they're trying to fold back. So anyway, let's just go ahead and give it a shot and see what happens here. They got some oily stuff on them. They're actually fairly responsive. So if you wipe these off, I would say these would probably be just fine. I was not expecting them to work that well. But yeah, works fine. Let's check one last thing. Let's see if how far it'll zero out. Oh, it does zero out. Takes it a while, but it does zero out. All right. So yeah, I'd have to say these are pretty decent. Just clean the crap off the leads. They're not gold-plated leads, though. They're just your standard, regular, everyday metal leads. Okay, here's the continuity test for the Probe Masters. Zeroes out faster. At least I think they do. Yeah. No problems there. Okay, let's go ahead and go to... let's bring out this resistance box. Set this right here. Put these in here. Hopefully this is not going to obstruct the view. As you can see, we're getting continuity reading. Okay. So as you can see, we're getting a pretty good size onboard reading, so that's going to be a problem. Again, shorter leads would probably, well, with this you're going to get onboard because it's a decade box. So there's 1 ohm. Again, it's reading at about half an ohm high. There's 10. Still a little high. 100. Yeah, same deal. 1K. That's fine there. 10K. Yeah, once you get into higher values, that doesn't matter so much. That's fine. 100K. We're good. 1 meg. Yeah, that's right on the money. 2 meg. Right on, pretty much. 4 meg. Again, right on. Just about right. All right, let's go to 10 meg. Slightly low as expected. Yeah, all right. And 11 megs. This is as high as I can go. Yeah, that's about right. So yeah, no problem on resistance. Just with lower value readings, you are going to have a problem. However, just to illustrate a point here, let me get this test board back on here real quick. I believe this is a 10 ohm on the right here. This resistor right here. And as you can see, it is reading it right because it is a little bit high. In fact, yep, there you go. It's a little bit slow on resistance, but not terrible. All right, so anyway, let's go to, let's do the capacitors. Again, I'm not even going to bother with this. Well, we can try it. Let's see what we get on capacitance. Yeah, look at that reading. I mean, that's just ridiculous. So it's going to make it impossible to measure this. So again, I'm not going to bother with these little ones. What we're going to do is we're just going to go with the shorter leads and see if that works better. If I can find the shorter leads. Yeah. Honestly, I think that's going to work a whole lot better. And I forgot to look at the screen to see if I was getting any readings before we plugged anything in, so yeah, try to get, okay. All right, we are not getting a reading, so that's good. So let's go ahead and connect some leads up here. Okay, we are still not getting any readings, so that's good. All right, let's put this down to the lowest setting of 100 picofarad. And it is reading it as 111, and this particular capacitor is a little bit on the high side. So that's about right. Okay, 150. I don't remember. I think this one does read a little bit high. 220 should be right on. And look at that, bullseye. 330 should be a bit low. Not quite as low as I was expecting, but it is low. 470 should be, yeah, that's about right. It's a little bit high. 560 should be a little bit low. In fact, 5.4 or 54 picofarads is what I was. 540 picofarads is what I was expecting, so that's perfect. 680, yeah, this is a little bit low. 820 should come in around 7.8. Yeah, that's close enough. That's about right on the 1 nanofarad. 1.5 should be a little bit low, and it is. 2.2 should be, yep, that's about, yeah, 2.282, 281 is usually what I get. 3.3, this should be low, and it is. It's about 3.05. All right, let's switch up to the bigger ones. 4.7, yeah, that's probably right. Yeah, that's about right on. 47, 4.7 nanofarads. 5.6 should be a little bit low. It is. 6.8 should be about 6.4. Yeah, that's fine. This should be around 8, and it is. 8 nanofarads. 10 should be a little bit, just slightly high, and it is. 15 should be, yeah, that's right. 22 should be pretty much right on, and it is. This should be a little bit high, up in the 34 range, and it is. This is a 33. 47 nanofarads. Yeah, 49 as I was expecting. 56 should be a little bit, yeah, about, that's right. 68 should be about 64. Yeah, that's fine. And this should be 102 or 103. It's reading it as 103.55. So with shorter leads, the only thing I can say about this meter and capacitance is use shorter leads. That's bottom line. It's kind of useless on capacitance on longer leads. Okay, here we go with the LED test. We've got red with reading, yellow with reading, green with no reading, lights it up fine. I was kind of expecting to see that since this is 20,000 count, because all other 20,000 counts have done that. Blue with no reading, and white lights up but no reading. Let's try the RGB. So we'll get red with the reading. I don't know if you can see that. Green with no reading, and blue with no reading. So it will light everything up. So if you need to test LEDs with this, it's just fine. Okay, let's go ahead and do the diode test. So we're going to start it off with the rectifier. Looks good. Fast recovery. Looks good. Schottky. Looks pretty good. Okay, switching. Looks good. And the germanium. And that also looks good. One thing looks like there is no continuity beep in diodes mode. Okay, so looks good there. Okay, so let's go ahead and bring the HT118A back up here. And we'll go ahead and get a reading on the output voltage. So we'll let its sibling do the honors, and we're getting a very healthy 3.232 volts. So it looks good. So this will light up anything. Shame it won't read the drop voltage, but that's okay. All right. Okay, so next up is the AC voltage test. We're going to just go ahead and just jam it into an AC outlet back here. So let's see what we get. Let's put it into AC voltage. That might help. There we go. Okay, and tonight's flavor is, ooh, it lights up red. Nice. So that indicates high voltage. Duty cycle of 59.9 hertz, which is correct, and 123 volts, which is about what I get. Let's go ahead and do a reading on the hertz and the duty cycle. And that's wavering a bit. So it's doing the same thing that my HT118A is. I think that's probably a software problem. Let me reverse it. Yeah, see, that's kind of all over the place. Okay, so here we go with the live test. One thing I did find out, unlike others, you actually have to use both probes for this. Okay, so we're going to stick them both in. And it gives the red indication and a beep warning, so that's cool. All right, so let's take these probes out, and we'll switch it over to NCV. Let's do it that way. I'd say that's pretty okay, let's do the overhead test on the LED light. Yeah. So the non-contact voltage is just fine. Okay, here's the Thermoprobe test. Let's go ahead and get these patched in. I'm going to try to do it without unwrapping this thing. And get this to a position where it will. Okay, so just the air temperature. Okay, the temperature right now is 76.1 in here. It is saying 76.2, so that's pretty darn accurate. All right, let's do the body heat test. Reacted fairly quickly. Should get up to about 93, 94. Okay, all right. And we got a new piece of kit here, a big lighter. The elongated one I had died on me, so we're going to use this. So here we go with the fire test. Yeah, I'd say we're good there. Set it on fire a little bit. So I would say this the Thermoprobe leads and this feature is actually, it's not 100% accurate, but it's pretty good. Okay, and here we go with the frequency test. The lowest I could get this to read stably at 2.5 volts amplitude was 6 hertz. And as you can see, the meter is reading 6 hertz. So let's go ahead and see how high this can go. We're going to go to 10 hertz first. Looks good there, and as you can see, the duty cycle also improved quite a bit. Let's see if we can get a little bit better angle on that. There we go. All right, so let's go to 100 hertz. Okay, 99.99 looks good. All right, let's go to 1K. .9999 kilohertz. All right, looks good. Duty cycle's holding good. All right, let's go to 10K. 9.999 kilohertz again. All right. Let's go to 100K. And it's 99.99 kilohertz. Okay, looks good there. Let's go to 1 meg. We're getting 0.9999 megahertz. Okay. And let's go ahead and go to 10 megahertz. And it is reading it as 9.999 megahertz. All right. Well, let's go ahead and try to get to 20. Over limit. That's what I thought. All right. So what we're going to do is I'm just going to drop. Okay, it'll read 19.9 megahertz. All right. It'll read 19.990 19.99 megahertz, okay? That's 19.995. 6. That's already that's going to max out here. Yep. So the maximum frequency reading that I'm getting on mine is 19.999 hertz, although it's actually 19.996 megahertz, not hertz. Anyway, there you go. It does appear to be operating within spec. Okay, and that brings me to the pros and the cons of the Kaiweets HT118E. First, the pros. Very good accuracy on all measurements. Have absolutely no complaints about anything. Everything pretty much was within spec. The capacitance was a little bit of a snafu, mainly because of the presence or lack thereof of a rel button. But there were ways to get around that. We'll get into that later. Very good count resolution. I'm glad to see that Kaiweets has released a 20,000 count meter, and they've done a pretty good job with it, in my opinion. Easy to use and a legible, well-written manual that's available in several different languages. It's not just your standard English and Chinese. I do believe there are several other languages available. Very decent display with always-on backlighting, which is a big deal. Every multimeter should have always-on backlighting, in my opinion, but hey, that's just me. But I'm glad that Kaiweets at least does it. Built-in jack safety features, the same exact features as you would find in the HT118A, with the flashy green lights telling you which jacks to to connect to. So for beginners, that's a really good thing. Solidly built, and it has a sturdy stand. I did not mention the stand, but it's every bit as good as its A sibling. Comes with a decent case. It's not anything special, but the fact that you get a case with it, keeps the dust off of it and all that good stuff. So yeah, I'm good with that. And it follows the same tradition as the HT118A in pretty much every aspect that you can think of. So yeah, I think it's a very well put together package here. Okay, now on to the cons. It is slow on high value capacitance readings, which is pretty typical of a meter in this price range. That's a minor complaint. The other thing is it's also difficult to take accurate readings below 1 nanofarad because of the lack of the rel feature to compensate the probes. I mean, this problem is also further exacerbated because with standard length leads, the meter often picks up 100 to 100 picofarads or more before the leads are even connected to the component, and sometimes more than that. Using short leads in this mode will work a lot better for capacitance measurements on the HT118E. And I would say, I think, I showed that it's a decent workaround. It's not a perfect fix, but it's certainly an improvement. Cannot read drop voltages on LEDs and diodes above 2 volts. That was pretty much to be expected, so I would say that's a minor complaint. And then, of course, again, I have to mention one more time, no rel feature. I'm sorry, but I have to give that a big thumbs down. Gotta have it on a meter with this level of resolution. Anyway, that brings me to the conclusion. And that is to say that Kaiweets has entered the 20,000 count world with the HT118E. My only question is what took them so long? In any case, it's good to see this company continue to come out with solid meters with higher and higher resolutions, offering higher precision on measurements. That's a good thing. Maybe one day we'll see them come out with a bench meter. I would really like to test a Kaiweets bench meter. I think that would be a lot of fun. Why still no rel function? That's my biggest beef with this meter, bar none. I mean, got to start including a rel feature. You've got multimeters that cost half this price that have that feature in. You've got to put that in. This is a great choice for an electronics bench, and it would also be a good choice as an all-around household meter. I mean, what's not to like? Well, the capacitance, but I'm going to stop harping on that. It has the same safety features offered by the HT118A with the green lights indicating which jacks to connect, making it suitable for a beginner. Overall, the HT118A builds on the success of its HT118A predecessor. It is a very accurate meter in its own right, and I definitely recommend it. I give this definite thumbs up. I do gripe about the capacitance, but otherwise, and it does, it does measure capacitance good. So anyway, that's going to do it for me. Sorry I was away for so long, and again, Kimberly, I'm sorry it took me so long to get to this, but we did get to it. Anyway, that's going to do it for me. This is Suey778, and thanks for watching the Kaiweets HT118E video. It's also difficult to take readings below 1 nanofarad because of the lack of a rel function to compensate your probes. This problem is further exacerbated because with and sometimes with standard length. Shit. Let's do it again.